All right, as discussed, we can find out from this magnitude and angle, so this value. So for this case, when we are talking about m1, which is this mass, which is in y, so which angle is 0, so it's straightforward. So it's like the y component is j. But when it comes to mass 2, which is basically in yz plane, so the magnitude by Pythagoras theorem you can work out. So for example, in this one, the magnitude is 3.24. So 3.24 is equal to magnitude of x component plus y component. So both have squares. So when you have two together, then in that case you just you need to work out x and y. So one of these equation. So what is it? Basically the components, two components, when you square them and add together and square root, this gives you the magnitude. Same way you can find out the angle. Angle is basically tan theta, a relation with tan theta. Tan theta is basically in Pythagoras theorem, so you will have y over x. So that's the way you find out. So for example, here in this case the theta is 120, so you plug in 120 and then you will work out what will be the y component or x component, or more precisely you can basically use y and z rather than x, because x is not involved here. So I would rather use z basically. So z plus y component, and y over z is basically your angle, right? So you can use these parameters to find out. So you have two unknowns, y and z, and two equations, so it's easily manageable. And when you're doing, you might face a little problem regarding the signs. So for example, here in this case it's written minus 1.62 and plus 2.81. So in this case you need to have the value of z as a 2.81 positive and y value, which is minus 1.62 j, so means it's a negative value. If let's say you find out they are not that way, so they have different signs, so you need to consult the figure basically. So in the very beginning I told you this mass 2 is has one component in this direction, so that's the axis. So one component in this direction, so this is the positive z direction. So you see you got a positive z direction component, right? And then it has y direction component which is downward. So downward means it's a negative y direction, so you have a negative y direction component. So this is something, so you need to consider actually. Again, when you're finding using these two equations, set of equations, to convert this information to that one, you need to use these two equations, z plus y square, the Pythagoras theorem, and then you got the tan theta is equal to y over z. So you will have a little bit different value, you might have, right? But the signs, ignore the signs. If let's say y or z is positive or negative, ignore those signs. Rather what you do, you look carefully the figure, if it has positive z or it has negative z, or same way for the y, if it has positive y or negative y. So you need to be careful. Then we have a the last one, which is not over here. So so f3, which I forgot. So you got f3 basically. uh, so you got m3 or 3 and omega square and angle theta 3. So this missing information is already in the book basically. So f3 is, this case is this one, 6.07. So you need to have 6.07, and then you got a, so this is pound, and then you angle is basically, you need to look at carefully what is the angle from positive y-axis. So all these angles are taken from positive y-axis. You need to take one consistent reference. So you start from here. So this is like 15 degree over here. So if you go all the way here to this angle, so you see this angle is 180 and it is further 15 degree. So you can use 15 degree further. So 180 plus 15, so it's 195. 195, and then yeah, so you need these two, so magnitude and angle, to find out the vector basically. Now you can find out vector, which is this value. You can just write over here, right? So again, whatever the sign, the values you get, some could be positive, some could be negative. Doesn't confuse. Do not confuse, because as I explained, this mass 3 is in, does have negative y direction, so that's why it is negative y. So that's why minus 5.86 j. So this is negative. And then you have a negative z as well, because this one has gone to another plane now. So it is towards negative z direction. So that's why we got negative z as well, minus 1.57 k. So this was very good example to understand this actually phenomena, where you have a magnitude and angle both to work out together. And that's it. So you first you need to get these three equations. So one for F1, F2, and F3. So you got for weight 1, weight 2, weight 3. Now you take a moment. What is a moment? So you take moment at A. So the question was, we need to work out what are the reaction forces at A and B. So at A, you take moment. So you have moment because of this force, this weight, this weight, this weight, and some moment at F at B basically, that is also causing moment. This is like a simple beam question you do basically. So first this one W. So you got 1, which is A. A is 1, so which is given over here. So 1 inch. It is in I direction. So here distance is not a scalar quantity, rather it's a vector quantity. So you got I, that is 1I basically means this is like in positive x direction, and this is the J part. W is a J, and we are taking cross product, right? Be careful with this one. So distance or displacement into force with a cross product. Now for the next one, so this is W3. So this vector we already found, F2, and it need to multiply that with the distance from here to here. So displacement. So A is 1, B is 2, so B is 2, so total is 3. So 3I. So you have to cross product. So you need to multiply 3 first with this part and then second with this part. Now the third one, weight 3, is basically again, we found this vector in the previous slide and the distance or the displacement. So you got A plus B plus A. So this distance is also A. So you have 4. And then the reaction force at B. So this FB is unknown. We cannot show which direction it is. Is it this direction or this direction, or it is in YZ plane, but it's unknown. So that's why we just write FB. And the displacement is 6 inch. That's also in I direction. So now you solve. Just make sure you understand the multiplication of vector. If you need to revise a little bit the fundamental, just go back to elementary multiplication of vectors. You will find it how you do that. So in very brief, when you multiply cross product of vector, you cross product of I with J, so the result would be K, right? So that's the way you do that basically, right? So within this equation, you will work out the FB value, and which has such components, the sum is getting to 0. So you solve this equation for FB. So this is the only unknown we have, FB, and we can work out basically, right? And another thing which you can do basically, So for all these components which are known, you find the answer, right? For example, yeah, so you have 1 into 9.72, so the answer for this product would be 9.72 K, right? So for this one, 3 into 1.62, so I and J will multiply and become K, and then next one will be, so it's a plus, so you will have plus, so you got 3 into 2.81, so this is I into K, and you will have J basically. So just go back and visit this elementary cross product of vectors basically, and you will, and then you form a vector of all these known values and bring this one to this side, right? So this will become minus, so you will get some vector over here, minus 6 in into fb, right? So now what you do basically, you find the summation in such way the left hand side and right hand side are equal. That's the way you do basically. So this vector, because division of vectors is not allowed, it's not possible to divide vector with vector, so we rather equalize basically. So you find such value of fb over here, you multiply that vector with 6i to get whatever this sum value is here, right? I'll say again. So you find out the summation of all these vectors together, that's the summation. Then what you do, you just find out such vector fb which must have j and k, because we are multiplying with I, so which has j and k components, so that we get this resultant over here, right? So that's what he has done. So we found this one. So then from here this step is quite straightforward actually, because what you do, you just scare this one, scare this one, scare this one, sum, and then take under root, and you will have the magnitude. An angle, as I said, you can find out tan theta. So tan theta can be determined by using this minus 0.36 divided by 3.10. Yeah, so this is the way you do the angle, and you work out what will be the angle here to minus. So just give it a go, try it yourself, and if you have any question, you can just ask again actually. But I'm quite sure you would need to revisit some of this vector multiplication equations actually. Uh, how you do that, then it won't be a difficult one actually. Okay, then, so this was first part was done, so moment at fb. Now we have mb, so we want to find out what's the moment over here. This will help us to find out fa, because you definitely got some reaction force at a as well. Process is same. The only difference here is, so these vectors are same, so this is w3 for example, this is w3. The only difference comes over here, because we are multiplying backward, the distance is going that way, so that's why instead of positive 2i we multiplied it with negative, because it's a negative displacement, because x is positive this way, so this is in this direction is negative. So for w3 across this distance, so this distance is in negative x direction, so that's why it's a minus 3i. And then same way, and then you have fb, which is now already determined. So this fb, uh, so 3.10, 0.36 basically, that's already determined. So that's already determined, and just you need to work out basically the moment at B. Yeah. So this is 5 is distance for this one. 5 is distance to this one. This is the distance is 5 inch, and 6 inches for FA. So here the FA. Yeah, sorry. So FB is basically because FB is vector passing through this one, so that's why we don't need to take the contribution for FB. We take moment at B. So FA will be the one which is unknown. So same way as we have done for FB, you will work out for FA. And as I explained earlier, what you do, you form a vector for all these known things and then bring this one to the other side, and then you basically what you do, you compare both sides such that they are equal. So that's why you will determine FA. It needs a little bit of practice. Just do it. It won't be difficult actually. And then yeah, you find out what's this vector, and then you find out what's the magnitude and respective angle as well. Angle, as I said, tan theta over tan theta is equal to this part over this part basically. Yeah, so note that these rotating directions and the static components caused by gravity are not included. Yeah, so the gravity effect is not been included in this one. All right, so we have next example 15.3. So the angular speed of system shown in figure 15.11 is 750 revolutions per minute. So we have the angular speed given. Determine A, the magnitude and orientation of reaction forces at A and B. So the first step is same as last example. So you need to work out so the reaction forces at A and B, and the magnitude and the location of correcting mass to be added at the radius of 0.25. And now the additional step is there, how much mass we need. So at a radius 0.25 is given, and we need to answer two things, first for mass and the location, right? So these are two views basically. If you look from the side, these masses are just in one plane in y direction basically, but when you look from the side, from the x y, so you see this is x z component, but if you look from the side, from this side, you see all these masses, they are spread out in x and y. So this is important basically. So all the angles are also given. So m1 is in x direction, y has a 45 with the wide y-axis, and from positive x-axis or negative y-axis basically is 150 m3. All right, so here the angular speed, yeah, so because we need in radians per second, so it's not really difficult. So you work out 750 revolutions per minute multiplied by 2 pi by 60, and this gives you radians per second. So that's the speed you have. So inertia force is also very simple to evaluate. So F1, which is m1 r1 omega square, F2 is m2 r2 omega square, F3 is m3 r3 omega square. All components are known, and we this time we have the standard unit, so that's why we are getting in Newton. You can use as a kilonewton as well. Uh, yeah, so it's up to you. So you can use kilonewton or Newton basically. So same thing. So we have three reaction forces, three inertia forces are there. Now the next step is the part A is reaction forces. So first of all, you need to work out what are the vectors basically. So you got the unit 14.80, which has zero angle. Now you see in this example, the reference axis is chosen as a positive x-axis. So you see this part, this is along the x-axis, which has zero angle, right? So it's really up to you which axis you choose. So So here last time it was y, positive y axis was chosen, but this time is positive x axis. Now you see the second one, F2, which is determined here, 5.55 kilonewton, and it has angle all the way up here. So what is it? So this one is 90. So this one is 90 plus 100 plus 45, which comes 135. F3 is negative 150, which is taken as a negative 150. You can literally write it as a so 180. So this is 180 plus this little part is 30. So 210. So it's the same thing basically. So this 180 is this one. You can write plus 210 or you can write minus 150. So both are things, same thing actually. And you will see that you can check it actually. You write minus 150, you convert to this vector, and there will be positive negative shuffle, but you will get the same values. Or if then you do with 210, you will get same values, but you need to be careful with the positive negative values. So now here you got, this is positive 14.80, this is a positive, so that's why it just have I. Then you got this component I and j. So now you see j is positive because it has so this one has a this M2 has one component this direction, right, and the second component in this direction. So you see y is positive, so that's why we got this one positive, and x is negative, so that's why we have this one is negative. And for third one, so third one has one component this direction and one component this direction. So you see both are in negative direction. So once again, when you want to convert with the standard equations, which I told you what is standard equation. So for example, in this case, it's a 5.55 is equal to under root, this time is x and y, so x square plus y square. Yeah. So and the other one is tan theta y over x. So you solve these two equations, and theta is given. Theta is 135 over here. So in this particular, so we have tan 135. So tan 135. So you just have two unknown, two equations, two unknown. You solve this straight away. You will get value of x and y. Don't worry about positive negative signs. You place positive negative based on the location of the mass. So this is at 45 degree. So it has x negative, y positive. So you just take that one actually. So you will find out these vectors, and then the process is the same. You take moment at A and B. So this time is taking moment at A, and what you got, because all masses are equal distance A. So what is A? A is 0.3. You need to understand this, and yeah. So A is just constant for all. So that's why we have written this in a bracket, and inside all the vectors. So you have F1, F2, and F3 together. So this is a little easy. So what you do, you solve all these three vector, and then you do the cross product. So, but one more thing, this little axis shown over here, this is important over here. So Z is positive this direction. So you are taking moment from here, moment at this one because of these masses. So that's why we have done negative distance covered. So that's why 0.3 is taken negative. Be careful with the displacement. Basically, displacement positive, negative, it really matters. In last one we had one case, one positive, negative. Same case is over here, but the z-axis is in different direction now. So we got z positive this direction. So if you take moment at a, this we are getting towards negative. So that's why we have minus negative 0.3 k. And then moment fb, which is unknown, we want to work out this one, and this has a distance of total a plus b, so a is 0.3, b is 0.2, right? So you can work out force. Again, don't confuse this one. Moment, so in the vectors, you are not allowed to divide vectors basically. So in the steps when you're doing, you shouldn't divide it. Rather, what you do, you solve this one, take this part to, to, to that direction, and then produce such vector fb which should be equal to this side. So I think these two examples, 15.2 and 15.3, would be greatly helpful for you to practice this basically. So you see, he has done it actually, this one. So in taking the cross product and rearrange, so solution of all these components, these ones, is this one, right? Is this one. So all this, so we just left with 0.5 k and fb. So you just bring this one to the other side, right? So that's why instead of minus 0.5, you left with positive 0.5 k, right? Now how to solve this equation basically is just what you do, you basically produce such vector, you write such vector. It's like backhand calculations. You do such values, you have this vector. For example, you want 0.5, you have 0.5 k, and what vector you will multiply to produce I. What you do, you write when k is multiplied with j, you produce I. So there must be some j value over here, and then you have j here. So k should be multiplied with I, so that you will have j. So here, for example, he has done this. So you have I and j components basically, right? Yeah. In fact, it is the magnitudes are divisible. So for example, you divide 0.5, 0.2 divided by 0.5, so you will have 1.72, and you got, because it's a negative, so there must be something you remember when you take cross products of vectors. So you got like I, j, and k basically, right? So if you multiply I with k, you have j, j multiply I, you have k, or k with j, you will have I. So this was like on a loop vector analysis, if you look back. So be careful with the positive negative sign. So the ultimate goal is you have such vector over here which can produce this resultant vector. This is like a comparing both, and that's it. So you got a moment solving the equation for fb. So you will have the fb vector which is determined, and then actually in this particular, because we had forces in one plane, so that's why he's making a little bit simplification over here. So what you're doing, so you sum up all forces to 0, you find out what is fb, you find out, you already know f1 2 3. So it's easily to do that. So you have fa, so you bring all the vectors to this direction, so that's why we got negative. So negative this one, negative this one, negative this one, negative this one. So all the sums you can plug in, and you can find out what's fa basically. Yeah. So this is the vector fa, right? So the question was, we need to work out what are the reaction forces at fa and fb. fb we found by taking moment, and fa just simple summation of different forces, right? So in fact, I would suggest you also try to find out same thing over here as well. So you got F1, F2, F3 and FB, right? So you already found. You don't need to take the second moment and just do this one, same thing. So you got FA plus F1 plus F2 plus F3 plus FB should be 0. So when FA is known, once you have in this one, if you have FB is known, so from this equation you can find out FA. Just try this one. If you get the same answer, that would be interesting to see. So we don't need to take moment at second plane basically for the B. All right, so he just used this equation to find out forces at A and B, and then that's it. So you have the value of FA been worked out, and let FC be the correcting force. Now you want to correct it basically. What you do? So correction mean you have to add mass somewhere along here, along this plane in XY plane, somewhere, so that the effect is cancelled out. So that's why what we do, we just consider only the forces which are over here, right? This is the B part, and then correction force. So sum should be 0, right? So remember, we are not considering the bearing reaction forces which we have determined in part A. We just are focusing on the masses which are given over here, right? So you plug in and then you find out. And then it's a simple. So you bring F1, F2, F3 on the other side and you work out what's your FC. So that's the FC you got. That's the correction force you got. And yeah, you can write in different way as well, 2.94 kilonewton, by finding magnitude and angle together. And now the what was asked, so this is the orientation 165. Remember, this is from the positive x-axis. So if I draw it, it will be, so somewhere is 135 is this line is 135, so 165, 66 is somewhere here basically, right? So this is it. Now we need to find out how much mass, because this distance is already given. So this distance is given 0.25, 0.25 distance is given, but we don't know how much mass we need basically. So for that one, this value will work out. So this one can be written as this equation. What is this equation? This one equation is same as we have used this one, right? So now we know what is a correction force we need. Mass is unknown, R is given, omega is same like this, and then you can work out. So that's why this equation is being rearranged, and we can find out what will be the mass required. 1.91 kilogram mass has been determined. So FC is 2.94 into 10 raised to 3. That's given over here. So this one is already determined, divided by distance 0.25 and omega, which was evaluated in the very first step. So that's the mass you determine. All right. Thank you.